The nuclear renaissance. Why atomic energy is making a comeback, even with the waste problem. What do you get when you combine skyrocketing energy demand, climate anxiety, and tech giants hungry for electricity? You get a comeback story brighter than a uranium rod. Welcome to the nuclear renaissance. Yes, nuclear power is having a moment. Once feared and criticized, it's now being reconsidered as one of our best bets for clean, reliable energy. But what's driving this sudden glow up for atomic energy? And what are we doing about the not-so-small problem of nuclear waste? Let's dive into the facts, the future, and a little bit of fission-powered fun. Why nuclear is back. For starters, nuclear energy gives us what other sources struggle with: consistent, carbon-free, high-output electricity. It currently supplies about 10% of the world's power, but its true strength lies in its ability to work 24/7, unlike solar and wind that depend on the weather. As nations aim for net zero emissions, nuclear power is back on the table. Big time. Reason 1, clean energy, no carbon. Nuclear plants don't emit carbon dioxide during operation. That's huge in a world trying to ditch fossil fuels. With wildfires, floods, and rising seas becoming everyday news, we need all the clean energy we can get. Wind and solar are part of the solution, but they can't do it alone. Nuclear helps fill the gaps with power that doesn't quit when the sun goes down or the wind stops blowing. Reason 2, it's reliable. Let's talk dependability. Your fridge, your lights, your phone chargers. They all need power on demand, not just when the sun's out. Nuclear reactors can run non-stop for 18 to 24 months before needing a refuel. That's base load power you can count on. Reason 3, AI and data centers. Now toss in AI. Training artificial intelligence models takes mountains of electricity. Tech companies like Microsoft and Google are investing in nuclear to power massive data centers. Imagine your next chatbot session being brought to you by a small modular reactor. Suddenly, nuclear power internet doesn't sound so far-fetched. Reason 4, better technology. Modern nuclear tech isn't stuck in the 1970s. And the small modular reactors, SMRs for short. These smaller factory-built reactors are cheaper, faster to deploy, and often safer. Some even aim to run on recycled nuclear waste. Yes, turning yesterday's trash into tomorrow's power. Talk about glow-up potential. But what about the waste? Okay, here comes the radioactive elephant in the room: nuclear waste. When fuel rods are spent, they're still dangerously radioactive for thousands of years. Currently, most of this waste is stored on-site in massive sealed dry casks. These are safe, very safe, but they're not a long-term solution. So what are we doing about it? Deep geological repositories. Some countries are going deep, literally. Finland is building the world's first deep geological repository for nuclear waste. It's called Onkalo, and it's like an underground hotel for radioactive material, with no checkouts for 100,000 years. France and Sweden are following suit. Meanwhile, the U.S. is still debating Yucca Mountain. Progress, but slowly. Recycling nuclear fuel. Some countries like France recycle spent fuel. They extract usable materials and reduce overall waste. But reprocessing is complex, expensive, and comes with political baggage. Still, future reactors may be able to use spent fuel more efficiently, shrinking waste and squeezing out more energy. Science fiction? Not quite. Just science catching up. Are SMRs the answer? Small modular reactors are exciting. They're compact, scalable, and ideal for smaller grids and isolated areas. But studies show they might produce waste that's more chemically reactive or harder to manage. In short, smaller doesn't always mean simpler. SMRs still need long-term waste solutions. They're not off the radioactive hook just yet. Public perception. Ask the average person about nuclear and they might say Chernobyl or Fukushima. That fear runs deep. Even The Simpsons didn't help. But facts tell a different story. Modern nuclear is among the safest form of energy based on deaths per kilowatt hour. New reactor design feature passive safety systems that automatically shut down if something goes wrong. Still, public trust takes time to rebuild. The verdict. Let's sum it up. Nuclear power is clean, consistent, and increasingly necessary. New reactors are safer and more efficient than ever. Waste is still a challenge, but solvable. Public fear and politics are slowing progress. Is nuclear perfect? No. But in the race for clean energy, it might be the imperfect hero we need. AI, climate, and energy security are forcing us to rethink old assumptions. And that means looking at nuclear not as the villain, but the underdog ready for a comeback. I'll see you again soon. Bye-bye, and thanks for reading, watching, and